This capstone is where the full architecture journey comes together. You'll connect business strategy, compliance, infrastructure, operations, tokenization, and stablecoin integration into one enterprise-ready platform package, then prepare to defend it in review and plan for implementation. Across the course, you've built the pieces of an enterprise-grade digital asset architecture: issuance flows, platform choices, token models, settlement, custody, compliance, security, integration, and deployment readiness. Now, the goal is to bring those decisions into one coherent package that executives, engineers, risk teams, and regulators can understand. Your capstone is more than a diagram. It is a decision package. It should connect the business problem, platform choice, architecture, compliance model, and rollout plan, so each stakeholder can judge whether the design is practical, defensible, and fit for purpose. Think of the capstone package as the evidence trail for your architecture. It connects the business problem, regulatory obligations, operating model, and stakeholder journeys to the technical choices you made. It also shows how the system works: reference architecture, components, integrations, deployment, token lifecycle, contracts, wallets, custody, and settlement. Compliance and security should appear as core architecture domains, not appendices. Every artifact should align, and every major decision should be traceable. Before choosing chains, wallets, or smart contracts, start with 3 questions: what asset, which investors, and whose rules? In digital issuance, business design and regulatory perimeter are not background context. They are architecture requirements. A reference architecture turns strategy into an operating model. The key question is what belongs on-chain and what stays off-chain. Identity checks, sanction screening, reporting, and most enterprise data usually remain off-chain for privacy and control. Token logic, settlement events, and shared state may sit on-chain. The API and orchestration layer connects these domains, enforcing policy across custody, banking, and user applications. Clear trust boundaries prevent confusion about data ownership, responsibility, and regulatory accountability. The token should be treated as an operating model, not just a balance entry. Each lifecycle event, onboarding, eligibility, minting, distribution, servicing, transfer, redemption, and burn, should trigger a controlled smart contract action. The architecture should separate token logic from compliance checks, role permissions, pause controls, and upgrade governance. For regulated assets, standards like ERC 1400 or ERC 3643 help encode restrictions while preserving interoperability. Every action should emit events for audit, reporting, and reconciliation. Wallet architecture is really a control model. First, decide who can hold or influence keys: a custodian, the investor, an MPC network, multi-sig signers, HSMs, smart contracts, or a hybrid. Then define the full key lifecycle from generation and storage to rotation, backup, recovery, and revocation. Finally, map approvals to risk. Transfers, treasury actions, contract upgrades, and emergencies all need clear limits: segregation of duties, monitoring, audit trails, and vendor responsibilities. Settlement design is where market structure becomes operational reality. Begin with the cash instrument: fiat rails, stablecoins, tokenized deposits, or a hybrid. Then control delivery versus payment, so the asset moves only when the cash leg is confirmed, ideally atomically. If one side fails, the design needs locks, timeouts, reversals, and escalation. Behind that sit treasury reserves, liquidity, reconciliation, and reporting, along with controls for congestion, delayed finality, failed payments, and counterparty risk. Compliance and security work best when they are designed as shared services across the platform, not added at the end. Identity checks, KYC, AML, sanction screening, and investor classification control who can enter. Transfer rules, monitoring, and audit trails control what they can do. Underneath, security should map to recognized frameworks like NIST, ISO 27001, SOC2, and internal controls. For smart contracts, add audits, pause mechanisms, upgrade governance, and emergency procedures so risk can be contained quickly. A defensible architecture package does not just state what you chose. It shows how you decided. Use matrices to compare platforms, custody vendors, jurisdictions, and operating constraints against consistent criteria. Then connect those choices to risk evidence, NIST CSF mapping, threat models, risk registers, readiness checks, and architecture decision records. This creates traceability from requirement to option, from option to risk, and from risk to control. That traceability is what makes the design credible in front of reviewers, auditors, and sponsors. Risk analysis should be specific enough to act on. Start with a risk register. Who owns the risk? How likely it is? How severe it would be? What control reduces it? And what residual risk remains? Then pressure test the system through threat modeling across wallets, APIs, smart contracts, custody, admin access, and integrations. Finally, map each control to NIST CSF functions and attach evidence such as audits, penetration tests, alerts, vendor reviews, and runbooks. A production-ready architecture needs a controlled path from development to live operations. Define each environment and make promotion between them evidence-based, not informal. SciCD should cover application code, smart contracts, infrastructure, and configuration. Before release, verify observability, backups, disaster recovery, access controls, runbooks, and support coverage. For blockchain systems, also include node operations, key management, chain monitoring, vendor SLAs, and clear approval gates for every production change. An architecture review is not just a presentation of features. It is a defense of decisions. Each reviewer will pressure test a different concern: business viability, security exposure, compliance fit, engineering feasibility, or operational resilience. Prepare by anticipating those questions and linking each answer to evidence: diagrams, risk analysis, control mappings, decision records, and checklists. Most importantly, explain trade-offs. Show what you chose, what you rejected, why it matters, and what actions remain before production. Your final deliverable is a defensible architecture package: business fit, regulatory posture, technology choices, security, compliance, integration, and deployment readiness. Use your matrices, architecture decision records, risks, and threat models as evidence. From here, you'll present the capstone, answer challenges, and move toward pilot planning.